Good afternoon, everyone. All right, so we've got an R51 Pathfinder in today. This is a 2010 vehicle. Now this vehicle's come in for a no crank, no start situation. There's a button that is cable tied onto the front of this vehicle, and that is a bypass button for the starter relay. So what's happening, I believe, with this, it's been to a few other shops, transmission shops. I'm not sure who else has looked at it, but initial concern was a TCM issue. From there, I believe it developed, or at the same time had a starter issue. Now, by starter issue, I mean a no crank situation. What we've found on this, and what this does happen on older vehicles, is the starter circuit, so the starter relay is actually controlled by the BCM and by the TCM. Now, the TCM in these is in the pan. The transmission control module is part of the valve body and everything in there, and then there's this big 10 pin plug here, which controls the TCM. So what we've found, I'll go over to the diagrams first up, or we'll start with the fault report actually, just to give everyone a bit of back info. If we have a look at this fault report, we've got faults here for CAN communication circuit, chain of ECU and immobilised. Now it's a past fault, so I'm not worried about the vehicle being immobilised at this stage. The other thing is it does run when you bypass the starter solenoid. EGR fault, not worried about it. ABS steering angle fault, not worried about it. But when we go down, we have CAN communication circuit faults with the TCM. So that's our main issue. The main thing we want to look into is the no com with the TCM. So obviously shift actuator control, etc, etc. Now, when we look into wiring diagrams, we've got two here. I'll start with a starter circuit. So if we have a look at this starter circuit, this vehicle has a starter relay up here, which is inside the IPDM. So there's a fuse block up in the top of this vehicle that is a module, and it does have a PCB mounted starter relay. This relay is controlled by this wire here, the N wire, which goes to pin 13 on the TCM, and it's grounded down here through this PCB module to the BCM. So the BCM and the TCM, one of them will supply a 12 volt ground to it. That will then obviously close this relay and allow 12 volts to flow through to the starter motor. What we're looking at here is we've got two issues, a no crank fault and a no com with a TCM, which are going to be tied together. Reason being, if we've got no TCM online, then it's not able to feed and control this internal relay. So we move away from this cranking issue, or the no crank issue, and we move to TCM fault now. Because my assumption is here that if we fix the TCM issue, then that will fix the cranking issue, because the TCM will be able to control that relay. So going over to the TCM, as you can see, automatic transmission module, it's internal to the automatic transmission assembly. 10 pin plug, looks like that. On here we've got 10 wires coming in. We've got a red and a blue wire, so R and Z, which are our 12 volt feeds from our fuse. We've got two black wires which are ground, so we're going to load test all four of those. These two wires here going up to this instrument cluster, I'm going to assume that this is a communication wire, just based on the fact that they're next to each other. It's probably CAN high and CAN low. Other wire is a diagnostic connector wire. It'll be like a K-line wire to TCM. There's a reverse light control, and then we've also got the park control and all that sort of stuff down here. So this shift selector module on these is actually mounted up on top of the TCM. So if we have a look up on, it's going to be hard to show. If you have a look up, sort of over there, need a torch. The shift selector unit's up there. Not worried about any of that at the minute. All we care about is TCM communication. So first thing we're going to do, powers, grounds, communication wires at the TCM. If that's all good, needs a new module. From there we can get the ball rolling. Alright, and first up, as you can see, we have a good CAN signal. We can pause that at the TCM. No distortion, nice kick up at the end. 2.5 volts. What have we got on CAN high? Sorry. 2.5 to about 3.5, and then CAN low we've got about 2.5 to 1.5, so that is good. Communication wise to the TCM good. This thing should be communicating. Last thing that we have to check is load test our powers and grounds, see if the module's got the capability to power up. If that's okay, then we know that this vehicle is going to need to start with a TCM, and we can take anything else we have to from there. All right, and powers and grounds, as you can see, we've got our brake light globe nicely lit, so that's load tested good. We're using the actual TCM wiring, we're not using a ground from the chassis or anything, so that's loading up the 12 volt feed and the ground. I'll switch it to the other 12 volt feed and the other ground now. All right, that's our other power feed, nice and bright, happy days. So 12 volt ground, all good, loaded up at the TCM. Network wiring good at the TCM. Other wiring don't care about with the park switch and reverse light control relay and all that sort of stuff. This vehicle is going to get a new TCM, well, if the customer wants it. From there, this thing should be able to control the start relay from the IPDM, but we're not going to go any further than that. Step by step, start with TCM. All right, here's a quick reminder just to check all the basics with wiring stuff. So I also went through with a front probe pin, so the right size terminal, and I noticed that the terminals were a little bit loose on that connector. Went through, snugged them all up a little bit, cleaned everything out, and we now have a park signal. So, foot on the brake. Oh, look at that, she's sorted. No dodgy button from the front. And this thing is good to go. Now, what I'm going to do is I'm actually going to double check and redo my work. I'm going to go through, and obviously I know the wiring's fine, that's good. I'm going to make sure those terminals are really good. I'm going to wiggle the connector at the TCM, make sure it's all sorted, and if that's the case, then this thing should be job done. All right, so just want to show everyone how we check terminal drag. So we've got these little probes, right? These little front probes are the appropriate terminal size for different types of automotive connectors. Now I've just tightened up this terminal specifically, and as you can see, this has drag on it. Like if I let that sort of sit there, it just rests, it doesn't actually fall straight out. So as you can see, there's drag on all these terminals now, like that. And that to me is good enough as far as this connector goes. So if we go through them all, you can see there's some sort of drag on pretty much all these terminals. I'm going to skip those two. That one's a little bit loose still. They're all pretty good now. So that connector drag, we just use a little front probe like that, and they're the appropriate size for different connectors. So we've got a whole kit of them, heaps of different sizes and shapes. We've got ones that we've made up as well off different vehicles, so like that's a female side, male big spade, etc. So that's how we do pin checks, and we can go through each connector pin and just check that there's some drag on it. So now we're going to clean out both sides again, put a little bit of dielectric grease, terrible shot, bit of dielectric grease on there just to make sure no moisture ever gets in there, and this should be sorted.